Hey guys, today you're going to be taking notes over special products that don't happen often, but you kind of have to know what the pattern is for them. Go ahead and title this Factoring Special Products, and your essential question is a two-part essential question. The first one is how do I recognize, and then how do I factor special products? The first special product out of the two, there's only two, is the difference of two squares pattern. Don't worry about writing this example. We have plenty of examples coming up. You should write down this algebra. However, I'm not going to talk much about it because I want to stay pretty constant to that box and diamond that we're still trying to get well at. All right. Before I start talking about the pattern, I need you guys to know what perfect squares are. And perfect squares are, for example, here's starting off easy. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 25, 6 squared, 36. The perfect squares are the 1, 4, 9, 6, 25, 36, and so on. The first pattern, difference of two squares, is when it's a binomial with subtraction, so has to be a binomial, has to have subtraction. It also has to be made up of nothing but perfect squares. So perfect, sorry, I'm going to abbreviate perfect squares because I'm running out of room. Okay. Example 1, binomial differences subtraction, and the perfect squares, remember there's this 1 in front of this x squared, is 1 and 36. We know that 1's perfect square is 1. We know that 36's perfect square is 6. So this one is, the answer to this one, x plus 6, x minus 6. X plus 6 times x minus 6. If you would like to use the diamond method, I said I would stick pretty true to that. Let's go to example 2 and I'll show you what happens in example 2. In example 2, do you see how it's a binomial? There is no m, which means it's 0m. Okay, when we're going into our diamond, our b is 0 because there is no m. And our C is still 100 because this one isn't written in standard form. So what multiplies to 100 but adds to 0? 10 times 10 multiplies to 100. One of these needs to be negative for it to add up to 0. And there we go. There's our perfect square. Our difference of two squares pattern. So it's going to be m plus 10 times m minus 10. All right, number 3, binomial, difference of subtraction. There is no n, so the b would be 0. C is negative 16, so what multiplies to negative 16 but adds up to 0? I know that 4 and 4 will multiply to 16. One of these needs to be negative in order to add up to 0. So the answer for number 3 is x plus 4, x minus 4. 4. We don't have a C again. Sorry, we don't have a B again. B is missing. There is no just H, so H is 0. And in between these two, between 16 and 49, we have to multiply those together. And 16 times 49 is 784. So this is a pretty big number. What might be easier for this problem is because it's a difference of two squares, it's one of the special ones, we can just think, okay, the perfect square of 16 is 4, the perfect square of 49 is 7. So this one will technically be 4h plus 7, 4h minus 7. I'm going to go back and talk about that diamond method for this problem. My suggestion, if you prefer to keep working with the diamond method and don't remember that you can just go ahead and find the perfect square, is when you're looking at the diamond, you know the sum needs to be 0, so they need to be opposites of each other. So when you look at 784, if you take the square root of it, because you don't want to divide by 2, that doesn't help you. You kind of want to figure out what times itself, because that's the only way you'll get the sum of 0 to be 784, and it's 28 and 28. One of those needs to be negative to get that difference of 0, and then you'll have to box it, and you'll get the same thing that we got here. All right, let's go to the next example. Our second perfect square trinomial pattern. Remember, don't write these examples. We're going to have a whole bunch. And it happens when we have a trinomial and there's something special going on with this trinomial. Let's just dive right into example 5. Using our diamond, B is -2 and C is 1. Okay, what adds up to -2 and multiplies to -1, -1, and -1. So let's go ahead and box it. Let's see here. M squared goes here, 1 goes here. Between these two, we're going to have -1m, -1m. All right, we have m is our greatest common factor. M is our greatest common factor. -1 and -1. What happened with this perfect square trinomial pattern is that you have the same binomial repeating, and we actually usually write it this way. And you did it. Okay, let's go to 6. All right, diamond and box, just to make sure that we're getting the hang of this. All right, we're going to have d squared, and we're going to have 25. Okay, then we're thinking what adds up to -10, what multiplies to 25? That's 5 and 5. For them to add up to a negative, they're both negative, so -5d, -5d. Okay, d's are greatest common factor, d's our greatest common factor, -5, -5, great. We'll have d minus 5 squared. All right, 7, last one. Okay, we're going to have z squared, 100. What adds up to 20 and multiplies to 100, adds up to 20, multiplies to 100, 10 and 10. So we'll have 10z, 10z, looking for my greatest common factor, z and z, 10 and 10. So this one is z plus 10 squared, because z plus 10 times z plus 10. All right, go ahead and work on these examples on the next slide on your. Go ahead and pause this video whenever you're ready. Okay, I'm going to start going over answers. 1, we should have gotten 5 minus 2x times 5 plus 2x. Remember, you can switch those and it's okay. You can have 5 plus 2x times 5 minus 2x. The perfect square of 25 is 5. The perfect square of 4 is 2. 2, we should have gotten n plus 1 squared. 3, we should have got y minus 10 squared. Solving the equation, make sure you're actually solving for when k is equal to 0, that 0 product property. And your first one is when k is -7/3. And your second answer is when k is 7/3. 5 is when t is 8. This one only has 1 because they're both the same binomial. Okay, you're ready to answer your essential question and go take that checkpoint. I hope you guys have a good day.